All right, so moving into module 3.1.2, previously we discussed that we at least got introduced to 4 R's, the right rate, right place, right source, right time. And as we move forward, we'll kind of discuss or at least break, kind of go into what each one of those little components means. All right, so this kind of brings us to our nutrients and why we need to make sure that we are optimizing our crop production. And so Levy's law of the minimum is basically saying that if you have a nutrient that is deficient, that the crop yield will only be proportional to the amount of that limiting nutrient. So, this barrel picture is common for when we're talking about Liebig's law of the minimum, in that if you have a sulfur deficiency, the yield will only be, it doesn't matter if all of these other ones are maxed out. If sulfur is deficient, then this will be the only, your yield will only be as much as that sulfur deficiency allows. And so this started out as nutrients, but what we also realized was that, maybe light and water and some of your other soil conditions are a factor, such as pH. You can have all of the nutrients available in the appropriate quantities, but if your pH is not proper, somewhere between 6 and 7, then you might not get the nutrient uptake that you expected. All right, so moving into right rate, right source, right place, right time. We want to make sure that we're applying our fertilizers in the right place. And the ways that we do that, many of us are familiar with broadcast fertilizer applications. Next, we have localized placement. And so this is kind of, when I'm thinking about this, I'm thinking like maybe drip irrigation, where you're applying that nutrient, or drip fertigation. You're applying that water and that nutrient exactly at the plant root, and those roots don't have to scavenge as much. And then foliar applications. So our broadcast is going to be the most economical. We can cover large areas. Many of us have seen this. You call the co-op up and you say, hey, I need you to come apply fertilizer to my field. They show up maybe with the big buggy. It's this big, huge machine, and it has this very wide spread. You can throw a lot of fertilizer and cover a lot of area in a very quick time. We typically use this in ranges and pastures, kind of our turfed area. You'll also see this in row crop as well, because we need to cover a lot of area very quickly. One of the issues is that we need to incorporate these fertilizers very quickly. So what we want to do is we want to try and apply that fertilizer right before a rain. However, if you're like me, you see the rain coming, you apply your fertilizer, and then the rain completely misses your field, and then rains on the other side. So sometimes this can be difficult to time, but it's very important, because when we apply certain fertilizers like urea, we run into the potential for volatilization. And when we go into the nitrogen cycle in the next submodule, you'll see that it's this volatilization that we're really kind of concerned with, because we lose a lot of our nutrients. We can lose up to 30% of the applied fertilizer if we don't get that incorporated into the soil. So you put out 100 pounds of nitrogen, 30% of that volatilizes, so you really only put out 70%. You paid for 100, you only got 70. That's not very efficient. Next, we have localized placement. This is kind of for our starter fertilizers. Also being able to, this is typically a lot better with liquid fertilizers because we can knife that in, and we can kind of make a slit in the soil, and that will kind of put a little band down, and then the roots can then have access to high content of nitrogen without having to scavenge for it. You might also see surface dribble or point injection. We have drip irrigation or fertigation. So for our starter fertilizers, here's that slit that was done with the coulter. And so there is a slit with a coulter. On the back side of that coulter, there is like a hose that releases a certain amount of fertilizer. And we can see that without a starter fertilizer, our plants are not growing very healthy when they're young. They also don't get enough root growth. And if we had a starter fertilizer, then now our plants are up. They've got the nutrients that they need to kind of get started and get growing. They cover this field very quickly. The canopy covers that. We kind of minimize the light that is hitting the soil, and we can at least slow down or minimize some of that root growth in there. Or I'm not sorry, root growth, the weed pressure. So our surface dribble or point injection is going to be where we apply this, either 2 inches to the side and 2 inches down, or we apply that on the surface and allow that fertilizer or nutrient to infiltrate into the soil. We would need rainfall for this to occur. But here, when we apply that underneath the soil, we call this a subsurface banded application. The fertilizer is already available to the plant roots. Drip irrigation or drip fertigation. This is where we run our drip tape. We apply the water, we apply the nutrients, and this is going to be for our high value crops. And that's also kind of the reason why they charge a little bit extra, is because they run this fertigation. This is a very expensive thing to install. But because they're high value and because we need to make sure that those roots are getting exactly the nutrients and the water that they need, we can charge a little bit extra premium for that. This is just a look at a very big drip irrigation system, in that we would have tanks. We have different nutrients, and we have injectors. We have this very complex electronic system, but ultimately that we are diluting some amount of fertilizer, some concentrated amount, to come into these drip lines and then apply the exact same amount of fertilizer to each one of these plants across the whole field. Next, we have foliar applications, and so these are going to be best for micronutrients. We don't want to apply macronutrients such as nitrogen or phosphorus or sulfur because plants need those macronutrients in pounds per acre. And so they're not going to absorb that much nutrient through the leaves. We'll actually burn that because we have that high salt content. And so that kind of goes to osmotic potential. Some of the things, this can be difficult to calibrate, but research has shown that micronutrients typically are better absorbed through the plant when they are applied as a foliar application. All right, at the right time. Like, we would not want to apply fertilizer in the fall, hoping that our spring plants would take that up. It's just kind of making sure that we're matching the plant uptake, the nutrient supply, with the plant uptake and demand. And so when the plant is growing, we know when the plant needs the most nutrients, and so we try to apply our fertilizers to at least match that demand. If we have too much fertilizer before or after that kind of window, where we open ourselves up to the potential for runoff or for some sort of it's not efficient. One of the problems with this, though, is that we need to conduct those field operations when the conditions make the application practical and feasible. And so, for this slide, when we start to apply these fertilizers here, this is typically when you want to go apply fertilizer or need to do something important to your plant. Typically, it's going to rain that week. I don't know why that is, but it just so seems to happen that, when we're at V3, V4, when we want to be applying V3, V4, kind of down in this area, when we want to apply our first side dress application of fertilizer, it typically rains that week and we can't get in the field. So the plant's still growing. It's going to miss that window, and then we can't get in, and we miss this kind of application or this feeding time for this plant, so that by the time we do get back in, the plant has kind of moved up to V6 or V7. We would want to apply another amount of fertilizer, because at V7, V8 is when the plant is going to need that nutrient. So knowing what growth stage our plants are at, and then also how much nutrient they can or cannot take up or need to take up, we can then start to develop that right time application for our nutrients. We also want to make sure that we're applying that at a time where we're going to minimize environmental loss. So, in the winter and the springtime is when we get a lot of precipitation. We have a lot of water in our soils. We can either have runoff or we can have percolation losses, and that runoff or percolation loss is going to take some of those nutrients with it. As you saw me mention previously, that split application or that side dress is the best management practice because you don't want to apply 100% of your fertilizer in the beginning of the season, right? You would want to make sure that you spread that out, because the plant is actually going to need more of that nitrogen in the later half of the season than it is in the beginning. And so that's one of the benefits of applying that starter fertilizer is you're already there, you're already planting, and then you come right back behind it and apply that starter fertilizer and kind of give it the food that it needs for that very beginning of the growth period. And then you can come back at V6 and apply your split application of, kind of like the bigger meal, the rest of your fertilizer when the plant actually needs it. The right rate is going to be determined by cropping history, your field observations. Typically, when you send your soil sample off, you'll get a recommended rate back. If you know that you're putting cover crops and you know that you're going to get, a 15 or 20% or 20 pound nitrogen credit, then you can kind of adjust that accordingly. Kind of the whole goal is to not have to apply fertilizer. And so also understanding kind of what your nutrient concentration is in your plant is going to help you understand how much fertilizer you actually need to apply. So we'll do this with tissue analysis and then also soil analysis. So we're going to soil sample in the beginning of the year. Excuse me. Soil sample in the beginning of the year to find out, what is actually there in the soil. Do we need to apply phosphorus? Do we need to apply sulfur? Which one of those are sufficient? And if we find that after, we've started our growing season and we still have a deficiency, then we will look to this plant tissue analysis to see what the deficiency would be. So we've kind of touched a little bit on soil sampling previously in Module 2 at the very beginning. One of the things we need to understand is that soil is variable. It is not a consistent medium. Things are going to change the way that the soil was kind of formed or developed. There's going to be some erosion. There will be the deposition of the soil. It is not consistent. So we want to make sure that we are, trying to account for that soil variability. And this kind of goes into our zones or our grids. And so we want to make a composite sample of that, of the zone that we're sampling. We want to take that sample to about 6 to 12 inches because that's our root depth. So we want to make sure that there's enough nutrient below the surface that the plant roots are actually taking up. and then the time of year. So are we going to do this pre-plant? Are we going to do this post-harvest? If you're really trying to maximize your nutrient use efficiency, you'll want to know what was there before, what you applied, and then what was left after harvest. So you can actually find out what the real plant uptake is, and you can adjust your fertilizer rates based on that. The method of extraction is going to be important depending on the region of the country that you're from. There will be several options for you to, when you look for your lab, find out what the method of extraction is. Typically in Tennessee, they do a Malic 3. From our soil test results, you'll get all of these components. And then from that, you'll determine what your rates and kind of give you an idea of interpreting that soil test report. When we interpret that soil test report, each lab is going to have something different for how they report that, but everything is pretty much similar. You're going to find organic matter, you're going to find phosphorus, potassium, magnesium, calcium, pH, and CEC. I think those are kind of at least the bare minimum of what they would give you for a soil analysis report. So within that, it will tell you kind of what the rating is for that. And so for phosphorus, we have 7 parts per million, and they would rate that as medium. Our organic matter is 5.2%. That's actually very good. We'll get magnesium, calcium. Our pH is 6.1, so we don't need to apply lime. Our CEC is about 7.5, so probably more of a kaolinite type soil that is probably going to need to be spoon-fed in order to optimize that crop production. Again, here we have, again, they're giving us what was available in the soil. The extractable cations and anions are NP205 and K2O, and then they'll give us a recommendation. And so that recommendation is applying 0.75 or 1 pound per 1,000 square foot every couple of months. It tells us to apply half rate of phosphorus, some potash. So they're going to give you an idea of what you should do as far as your nutrient management plan. This is from Waypoint. This is out of Memphis, and I really like these because it gives me, I can look here very quickly and see where I'm deficient at. So I know that I'm deficient in phosphorus and potassium. I don't need to apply calcium, magnesium, sulfur, and I'm pretty kind of okay on my micronutrients. I probably need a little bit more organic matter. So they kind of give you these ratings as a bar chart, and you can see that very quickly. Our cation exchange capacity is 20.7. The milliequivalents per 100 grams of soil is the same thing as centimoles of charge per kilogram. So here we have a CEC of about 21, and that's actually pretty good. So we know that our soil can hold the nutrients that we're going to apply. And our pH is 8.1, so we don't need to apply lime. Just to look at some of the different, everyone's going to have their own kind of layout, how they want to interpret that or get that back to you. But most of the time you will get some rating, high, low, medium, very high, in order to kind of understand what this means in your soil test report. All right, next we have the right rate. And so that right rate, as we talked about, is going to be based on your soil samples and kind of what you actually need to apply for the plant to optimize the yield. And so one of the problems that we have is that if 100 pounds of nitrogen is good, then 200 pounds would be better. And that's not always the case because fertilizer is not a linear. You don't get an X amount of growth for, or a Y amount of growth for X amount of fertilizer that you apply. So that is going to be the relationship between yield and nitrogen, or our nutrients that are in there. There have been several studies done to determine what the optimum nitrogen requirement is in order to optimize yield. I don't like using the term maximize because we can apply, we can apply the appropriate amount of nutrients to our crops. There are corn growing competitions, and they spend an awful lot of time making sure that the plant has all the water, all the nutrients. All of C. Hopkins Cafe, managed by my cousin Mokul Nina, they spend a large amount of time trying to maximize that crop yield. But that's not actually practical for those who are trying to grow, 1,000 acres worth of corn. It's just not feasible. And then making sure that we understand our nutrient credits. So we can have manure applications. Remember that when we apply our legume cover crops, we're going to get a net mineralization. And then there's also possibly some nitrates, hopefully not too much, but there's possibly some nitrates in the irrigation water that will give you an extra little boost. So we want to make sure that we're not buying a lot of fertilizer. So as I mentioned before, that applying nutrients or applying fertilizer does not result in a one-for-one yield. It is not a linear thing. So that if I apply 300 pounds of nitrogen, I should get 600 bushels of corn. It's actually what we call the law of diminishing returns, in that you can only get so much yield for the nitrogen that you apply. Anything else after this, you do not get the yield increase that justifies the cost. So finding out that optimum nitrogen rate to optimize corn yield is actually going to benefit you economically. So one of the things that I want to tell people, or at least get producers to understand, is that, do you want to win at the diner or do you want to win at the bank? Do you want to be the one that's sitting in the diner boasting about how much yield you got, but you actually didn't make a lot of money? Or would you rather be the person who is kind of quiet in the diner, didn't really get the greatest yield, but you actually got the best return on your investment? And that's really what we need to get down to, is return on investment, so that we have money that we can continue to grow our crops. So we need to be, not only do we need to be environmentally sustainable, but we also need to be economically sustainable. And there's kind of the balance between that, but they actually kind of go hand in hand. So this law of diminishing returns is basically that you can only get so much yield for fertilizer or nutrient input, and we need to kind of find out where that is. And then also we have the right source. And so knowing what your different fertilizer materials are, this is going to help you determine what you need to apply. For our nitrogen fertilizers, one of the most common one is going to be urea. That is a 4600. And then another one that you'll find very common is going to be urea ammonium sulfate. And you'll see this as a 330012S. And so this S means that there is has 12% sulfur in this fertilizer material. And we'll talk about this in the sulfur module. For the most part, our phosphorus fertilizer materials are going to be mono or diammonium phosphate. You might hear this as MAP, monoammonium phosphate, MAP. And you'll hear this as DAP, diammonium phosphate. And so we can see that we have a little bit of nitrogen, we have a high phosphorus content, so we don't need to apply a lot of this fertilizer. And we'll get a nitrogen credit for that. So if you remember in our calculations, I had you use some of these materials and understand that if you apply 100 pounds of this monoammonium phosphate, you're going to get 11-pound nitrogen credit. So being aware of that is going to help you minimize how much actual nitrogen fertilizer that you're buying. For our phosphorus, for our potassium, what you'll typically see is muriate of potash. That's a 0060, got a high K content, dissolves pretty good, moves into the soil easily. You'll also see potassium sulfate. Again, we're trying to get some of that sulfur back into our soils. Maybe potassium nitrate. This is something that we would use in more of a greenhouse setting. And then you might also see something called sulfomag. And that just has, it's potassium, but it's also sulfur and magnesium. All right, I know that was kind of a long video, but that is all of Module 3.1. So after this, you should be able to complete Quiz 3.1, and we will move into the nitrogen cycle, and I'll be referring back to this module as we move into these other different nutrient cyclings. All right.